Hello everyone, in this video we're going to talk about how to classify triangles. So there's two ways we can classify triangles. One, we can classify them by their sides, and two, we can classify them by their angles. So when we talk about classifying triangles by sides, we have three names that we might give a triangle. So we have scalene, we have isosceles, and we have equilateral. So scalene means that we're going to have no congruent sides. So all three sides of the triangle will be a different length. Isosceles, we have at least two congruent sides. So keyword there, at least. We need two congruent sides for sure. That's what most people probably recognize the definition of isosceles as, but really it's at least two. So if we have more than two, as in three congruent sides like we see on equilateral, then we're going to call that an equilateral triangle, but an equilateral triangle is also an isosceles triangle as well, okay? But more specifically, three congruent sides we will call equilateral. And we can classify by angles. So by angles, we have actually four names that we could give to a triangle. We have an acute triangle, which means we have three acute angles or three angles that are less than 90 degrees in measure. We could have a right triangle, which just means we have one of our angles of our triangle is a 90-degree angle. And we could have an obtuse, which means we have one obtuse angle, so one angle that is more than 90 degrees in measure. And lastly, we could have an equiangular triangle, which means all three angles are the same measure. That measure would be 60 degrees, okay? So when we classify triangles, we can classify them by sides and angles, and we can name them with both. So we could have a scalene acute triangle, or we could have a scalene right triangle, or we could have an equilateral equiangular triangle, okay? So we're gonna look at one example where we could see this in a coordinate plane. And the reason why we're going to look at this example is because we have to think about some of the other things that we've talked about in geometry and apply them to this question, right? Because if we just look at a triangle, it's going to be fairly easy to tell, oh, it is a right triangle, or it is a scalene triangle, right? Just depending on what the markings are on the triangle. Well, in this case, it's on a coordinate plane, so we have to kind of mathematically come up with what our answer is for the type of triangle. So we want to classify it by its sides, okay? So for sides, we want to talk about, is it scalene, is it isosceles, or is it an equilateral triangle, right? So that would be by sides. And then it just says, determine if it is a right triangle, okay? So we need to remember, hey, the slopes of two perpendicular, or two lines that are perpendicular, are going to have opposite reciprocals. That's important because that's where a 90-degree angle is formed at the intersection of two perpendicular lines. So we'll get to that in the second part. The first thing we want to do is classify it by its sides. So we need to know the distance, or in other words, the length of each side of this triangle. So we need to use the distance formula to help us know what our distances are, okay? So let's start off with the distance from A to B, right? So that's going to be this distance right here at the top. Okay, so remember our distance formula is the square root of big long square root, and we're going to say x2 minus x1 squared plus y2 minus y1 squared, okay? All right, so we can fill this information in, and let's go with, x1, y1, x2, y2. So let's say 6 plus 1, because that's 6 minus negative 1. And we're going to do 3 minus 2, okay? So when we simplify this, we're going to get 7 squared plus 1 squared. So we end up with 49 plus 1, which is the square root of 50. Okay, so the distance from A to B, we're going to say is the square root of 50. All right, we'll just leave it as that for right now. And I'll write that up here so that we can kind of refer back to it. Okay, so the square root of 50. And now let's take this information away so we can do the distance of two other points. So now let's do the distance from B to C, okay? So B to C, change up our letters there, and let's write our distance formula. Okay, so now let's let x1, y1 be 0, 0. So we're still working with 6, 3. So we're going to do 6 minus 0 squared plus 3 minus 0 squared. So a little bit easier on this one for our distance formula. So we get 6 squared plus 3 squared. And that's going to give us 36 plus 9. So we end up with the square root of 45. Okay, so we can leave that as a square root of 45 right now and just write it right there, square root of 45. Okay, and so now let's find the distance of our last side of our triangle so that we can tell if it's scalene, isosceles, or, well, we already know it's not equilateral because we have two sides that are different already. And the last one that we're going to find is from A to C. Okay, so let's let A now be x2 and y2. Okay, all right, so now we're going to say -1 minus 0 squared plus 2 minus 0 squared. So -1 minus 0 will be -1, so -1 squared plus 2 squared. And we end up with 1 plus 4, which is the square root of 5. Okay. All right, so now we look at our three sides. We have square root of 50, square root of 45, and the square root of 5. So all of those are different. And so we are going to say that this is a scalene triangle, right? All three sides are different, or in other words, there are no congruent sides. Okay. Now it says determine if the triangle is a right triangle. Okay, so we can delete this to give us some room. And so now we need to figure out the slope of each line to determine if it's a right triangle. Well, we can see up here at this intersection that is not going to be a right angle, right? That is an acute angle. It is very small, so I don't need to find the slope, or I don't need to compare the slopes of AB and BC, right? But I can see maybe there might be a right angle down here, okay? So let's find the slope of AC, okay? So we can do this by using the slope formula, or you can just use rise over run. So if we're going to use, let's say, rise over run, then we could say we're going down 1, 2, and right 1. So that would be down 2, right 1. So we have a slope of -2, okay? And let's find the slope of BC. Okay, so BC, we could go down 1, 2, 3, and left 1, 2, 3, 4, 5, 6. So down 3 and left 6. So that's going to give us 1/2. And now look what we've done with our slopes, right? We have opposite reciprocals, or the product of those two slopes is -1. So these two lines are going to be perpendicular. And since we have perpendicular lines, we can draw our right angle box in there, and we can say, yes, it is a right triangle. So our final answer, we could say triangle ABC is a scalene right triangle. Okay, and that is how you classify triangles in geometry.